Hey, what's up guys? Welcome to Deep Tensor channel. Okay, in this video we are going to take our 4 rules WWWH on exploding gradient. We will discuss what is exploding gradient, why exploding gradient happening, when exploding gradient happening, and how we can prevent it with some solutions in the future. So let's get started with what is exploding gradient with a fun example. As you can see, suppose you are playing an Angry Bird game. If you don't know Angry Birds, it's a game to pull your red bird here to arrive the target here and crash it, which is the pet. Suppose, let's imagine that if we pull this bird, your Angry Bird here, the red one, with some extra power, you will end up that the bird will go far away than the target and will not crash the pet here. So this is the right one and this is the bad one. So let's link this scenario with exploding gradient. When your cost function are very big, which represents the extra power given to the bird, as shown in this image, your bird will be here, this big black point. Okay. What if you give the cost function a derivative with high value and subsequently the cost function in the next iteration higher than the previous? So the cost function in iteration 1 equal 0.5, this is for example, and cost function in iteration 2 equal 0.8. So this is a big difference between the first cost function and the second one. The normal case is when the cost function in the first iteration is 0.5, it should be decreased, not increased. When you see this kind of two scenarios to detect the exploding gradient, when the cost function is dramatically increased or with none values in the cost function, then you can say you have exploding gradient. So how we can solve this kind of problem? We can solve it using something called residual neural networks. When we have a very deep neural networks, we can apply the residual neural networks, which is an idea introduced in 2050 in paper titled Deep Residual Learning for Image Recognition. I will give you the link in the video description. The idea behind this great approach that there is a connection called skip connection. This skip connection take the activation parameters from the early layer and add it to the current activation parameters or the current calculation, as we can see in the right image, which is a small scope of a very deep neural networks here. So how this process is done mathematically? Let's take the image in the right, in a new page. We have in this image 3 layers. Let's say this is layer 1, layer 2, and layer 3. Okay. From the image, we have 3 layers. Skip connection connects the layer 1 with layer 3. So in normal case, without skip connection, the methodology of activation should be looks like this. A3 equal G of Z of 3, where G is the activation function and Z or Z is the weights values that should be calculated here. Z3 equal W3 times the activation from the previous layer, A2, plus P3 the pies. But in case of skip connection or residual methodology, we can say the activation function will be looks like this. A3 equal G of Z of 3 plus the activation in layer 1 here. As you can see, we added the activation parameters or the informations from layer 1 added to layer 3. And of course, Z3 equal W3 times A2 or multiplied by A2 plus P3. Okay, great. Actually, it's not necessary if we make the skip connection after 2 layers like our example from layer 1 to layer 3. It can be after 8 layers or 5 layers or what you want. But remember one consideration. It depends on the number of layers in the neural networks model. From the researchers and publications in the top conferences and journals, they made a small comparison of the accuracy performance between the neural networks with a skip connection or with residual methodology and neural networks without it. Let's plot the error versus the number of layers. They figure out that it should be, in theory, when we increase the number of layers and make a very deep neural networks, it should be decreases exponentially. But the fun fact, this is a theoretical assumption. But in reality, after a specific point, the error starts to increase again like this. The good news, after the residual neural networks discovered, no matter how neural networks is deep, the error decreases exponentially like this. Another solution could be taken in your consideration that we know that the gradient values increases immediately and have a very huge values. We can solve this issue with something called gradient clipping or penalty gradient. Like we have a specific threshold that limits the gradients and reset this gradient when it exceeds the limits. Also, we can make the clipper or the penalty on the weights. And that's it in our mini course. Hope you understand the vanishing versus exploding gradient very well. Let me know if you have any other concerns or questions in the comments. Thanks and see you again.